Welcome back. So this is Deep Dive on AWS Fargate. If you were not in the State of the Union this morning, quick overview of what Fargate is. So not a service, underlying technology for container management. So kind of like containers on demand without needing to scale or modify the underlying infrastructure. So everything at the container level scale seamlessly based on demand. It's resource-based pricing. So more similar to the Lambda model maybe than to the traditional EC2 model. So what does that mean in practice? So I think Fargate's more about what you don't have to do anymore, which is kind of a funny way of looking at it. But there's a lot of pieces that go into managing a production container workload, right? So really easy to do one container, not so easy to do 1,000 containers. Fargate takes a lot of that away. And it doesn't mean that it's not happening, but it's happening in the background for you. So things like scaling or service mesh or discovery, the resources that belong to your actual cluster, those things are not managed by you anymore. So you manage everything at the container level. You pass Fargate your task definition of your pod, which is basically describing what your job is, and then you're done. So why Fargate? So running a container locally is really easy, right? And you know it's really easy because there's 10 million little, I did ECS in a weekend, or replace everything you've ever done with Lambda. And that stuff is really easy, right? So writing a demo app, deploying some sort of sample, that stuff is really easy. But it gets harder the more of them you add. So running a couple containers is a little less easy, but it's starting to get to the point where maybe I need some sort of orchestration tool to manage them for me. But eventually you get to the point where if you want to run something in production, you have more requirements than you do if you're just running it locally. So if I just run a container locally, I don't really care if every once in a while it fails, or every once in a while I drop a request. Every once in a while there's a little period of emptiness where I restart something, or when something didn't gracefully drain off connections. But you get a lot less tolerant for that when you're running things in production. And with containers, not only are you worrying about what you're managing, but there's a lot more pieces. So instead of just worrying about one app that handles requests gracefully and drains off connections and is discoverable by something else, you end up with lots of these moving boxes. And there are, so obviously, pros and cons. So ECS made that a little bit easier. So the same goes for something like Kubernetes, right? Is that you end up with this layer, so your orchestration tool, which helps you manage everything else. So how do I scale? How do I manage? How do I deploy new copies of something? How do I know out of my pool of instances, which instance do I place this task on? Obviously, my VPN is back, but I need it this time, so I can't ignore it. But even with an orchestration tool, you're not totally hands-off yet. So although it kind of looks like, well, great, I have this whole layer, and it's taking care of my scheduling and my orchestration, and it's managing my cluster, and it's managing my resources, and it's placing my tasks for you. That's not totally hands-free, right? So there's still other things that when you look at these instances, you're still responsible for. So an example of this might be an agent, whether it's the ECS agent or something else. A lot of people run like logging and monitoring agents. So those are all things that you still have to do on your host. So you still have to do version upgrades. You still have to keep the Docker agent running, because Docker has a daemon that you use to communicate over the Docker socket. So there are still things that you're responsible for, even if you're using an orchestration layer. What Fargate is removing another set of those pieces. So anything that you did on the host before. So an example of how I would have done this in production is I had the ECS agent. I had to make sure that Docker was running, although if you're using an ECS or Kubernetes, it's slightly less. But I had to make sure that those are running. For my applications, maybe it was pretty early, so there weren't a lot of log driver options. So I logged everything to var log messages because I needed really early startup messages, but I was responsible for all of that. So I'm responsible for collecting my logs from a container. I'm responsible for then shipping them back somewhere else, whether that's CloudWatch or another logging system. I'm responsible for all of those pieces. I'm responsible for updating my agent when ECS needs an update. I'm responsible for making sure Docker's running. There's lots of pieces that, regardless of my orchestration tool, I still have to do. So Fargate takes part of that away. So anything happening at the cluster level, I'm no longer responsible for. So what it leaves me with is basically that piece that was in the middle for us. So I'm only responsible for the little services that are running in that pool of resources. So what does that mean in practice? Running Fargate containers in ECS, it ends up being, and we'll look at what the building blocks of this is, but it ends up being a very similar piece to what you do with an ECS or later with Kubernetes. But it's just the description of your job. And in our case, that's a container. So for ECS, it's called a task definition. There's 2 launch types. So I mentioned this morning, and I'll mention it again. So you can do hybrid clusters this way. So if I have some things that I want to run as the kind of the traditional way, so I want to modify my cluster resources, I need to change things. Sorry? Oh. I can do either Fargate or I can do EC2. So EC2, I can change my networking type. I can change the underlying host. Fargate, I don't have that, but I just pass it my task definition. Resource-based pricing, so it's kind of like Lambda, so it's based on the actual task itself. Same task definition. So if I can run something with launch type EC2, so the kind of the normal ECS way of doing things, I can run that same container in Fargate mode. So I tell it that it needs to run in Fargate mode, but it's the same kind of task definition. So if you have task definitions written for ECS already, you can just run the same task definitions in Fargate. So easy to switch back and forth. For now, that's also how you'd handle something like execing into the container and debugging. So there's nothing to exec into, because to exec into a running container, I have to first be a part of the host. And since I can't do that in Fargate, if I needed to do that for a running task in Fargate, I would probably just switch it over to EC2. So compatible with each other, I can use those same definitions to define the same container back and forth. A lot of the pieces should feel very similar to ECS. So your task definition and your container definition, you're basically defining a bunch of requirements. So the resources that I need, where I'm getting my image from, this is all really the same thing. It's just a different launch type. And what I'm removing then is all those extra things that go along with managing the cluster. So the idea here is, why should I have to manage cluster infrastructure to just run a container? Isolated at the cluster level. So although you're not responsible for it, you're isolated at the cluster level. Same behavior, by the way, so you have a couple less choices in Fargate, but the same behavior as you get with ECS. So since it's going through the load balancer, you set the number of healthy copies that you need of your task, and then it will replace them automatically when they don't work anymore. Is everyone here either working with ECS or is familiar with what I'm talking about, with what a task definition is? Question or yes? Okay. I wasn't sure which one that was. Okay, so if you don't know, we'll go over it really quickly. Task definition, it just describes what you're doing. So it says your resources, where you're getting your image from. You can also control some extra options like your log driver, some of the flags that you pass to Docker you can do in your task definition. You have a couple things that you have to have, and a lot of them are immutable. So your task definition itself is immutable, but there are some things that you can't change inside your task definition also. So you need a family, you need a name, and you need to pull your image from somewhere. How it works, so we end up pulling from a registry, right? So if I want to deploy something into ECS, my flow pretty much goes, I build my image, I push it to some kind of registry. So in a lot of cases, it might be ECR, which is the Amazon registry, or it might be something like Docker Hub. It might be a private registry if you're into that sort of thing. I build it locally, I push it to my registry, I write a task definition, which has the location of that image, and then I can deploy that task definition as part of a service onto ECS. Same basic concepts here, but we'll show in a little bit. We end up skipping some of them. So a really ugly colored version of what cluster level isolation looks like. So I get a lot of people that ask, how should I set up my cluster? So how do I know when I need multiple clusters, or how do I know when I'm okay to share a cluster? generally how I've done it in the past is I separate based on environment. So I have a prod one, I have a development cluster, I might have a staging cluster, I might have a test cluster, but I tend to separate that way. So it works really well with the boundaries inside ECS, since you're separating everything at the cluster level. And that means that I can get a pretty reasonable copy of my production infrastructure as part of my staging infrastructure. So I can deploy the same task definition, probably with different environment variables, but I can deploy those same things to a staging environment before I test in a production environment. So it gets me a really nice flow of how I'm testing and QAing changes before they make it out to production. So pretty much the only thing other than where your image is coming from, and we'll walk through how to do this. But pretty much the only thing that I care about for Fargate at a kind of a deep level is resource usage. So how do I know how much CPU or memory my task needs, and how much of the whole should I let it take up? So you have task level resources and you have container level resources. You get some options with Fargate, so it's not all of the options. So you get a couple different choices of CPU versus memory. You set those when you run your task definition. So that's pretty much the main thing that you're doing. And I'll show you in the console. But we set our task definition and then we give it some limits also. So there's hard and soft limits here. So task CPU is hard. So I don't have to give it a container value. I am required to give it a task value. So if I don't do anything, all containers will get an equal share. However, if I have one that doesn't need a lot of resources, or I have one that needs extra resources, I can change that myself. So by default, and we talked about this before, right? But we're two things that we're looking for. We're looking for a sensible default, and then we're looking for how can I customize this if I want to tune my resources better. This is the kind of thing that I'm talking about. So if I don't do anything, if I just leave it the way that it is, and I don't want to tune anything, it will just get an equal share. But if I know that one container is really resource hungry and one is not, I can change that myself. Can also do, so this is an example, by the way, and I have some links somewhere in here, but there's a demo application that has a Fargate branch from AWS Labs, and it's a Scorekeep app. So if you're looking for a demo app with a couple of different pieces, there's a pretty good walkthrough. I'll post a link, but it's the Scorekeep lab on AWS Labs, and that has a couple different pieces to it that will show you if you use it's an ECS demo, but you can run it in Fargate also. So that's where the examples are coming from in here. So the orange ones are coming from that app. So you can see in the demo app, if you go to AWS Labs, you can match up what your app is doing with the examples in here. So you can follow along with that too. Same thing for memory. So you get the task is hard. You don't have to set the memory level ones. By default, that memory is available to all the containers running on there. You can, again, tune it and specify your own limits. You can see that they're working out of the same pool, and then they each have a reservation, and then all of that extra memory is available to every single one. If you set a hard upper limit on memory, you can't go behind that, so past that. So when you end up with those errors that say task number or whatever was killed for out of memory usage, this is it. It's exceeded its hard limit and it was killed. Platform version, basically controlling the runtime that you're using around your task. So that's something that we will make new versions available to as things are updated. So that would be like a kernel update, a bug fix, a security update. What this means though is explicit control though. So since you're basically running those in our compute pool for you, if you leave it blank, we'll automatically update it. If you don't, if for some reason, if you don't work at a small startup maybe and you have compliance rules, you can also set the runtime that you need to be kept at, and then you can explicitly choose. I'm going to cover networking a little bit. So too much networking right after lunch will make everyone fall asleep. So the diagrams, by the way, will probably be a little small in here, but we'll post the slides again. So if you want to look at the VPC diagrams, at a time where they look a little bit bigger. They'll be in the slides also. So in Fargate, tasks run in AWS VPC networking mode, which means that each task has its own network interface, so its own ENI. That is the default. You do not have the option to use another networking mode in Fargate. So this is one of the things that if you require another networking mode, then Fargate is not it for right now. So you get control for your network access through your security groups and through network ACLs. It supports public IP. The way that it ends up looking is when you launch your task into subnets, we create that ENI for you. We allocate it a private IP from that subnet that you launched it into. The ENI gets attached to the task, and then that private IP now belongs to the task. So private IP per task. You can also assign it a public IP. Security groups are what does the inbound and outbound access, but you go across subnets and across multiple availability zones. So it's a little hard to see from the diagram because there's a lot of stuff going on in there. But start with a private IP. You can also assign a public IP. That's per task. So when we talked about in the State of the Union this morning for containers, how things are kind of moving to a task as that primitive, this is the kind of stuff that I'm talking about. So instead of just having the IP address that belongs to the whole instance, the ENI is per task. So each task has its own IP address. Which is really looking at exactly at the level that I want it to, right? Because I can't manage my cluster infrastructure. So instead, I control and manage everything at the container or task level. I just said that, so you can ignore the little orange box, no other networking modes. This is an example of the run task command where you'd use this. So we mentioned platform version. This is passing in latest, so it'll update it for me. But then you can see that we pass all the networking configuration. So I give it some subnets. I give it a security group ID. You also can do that in the console. So everyone's always like, well, why don't you do more VPC demos from the CLI? And it's like, have you ever tried making a VPC from the CLI? We'd be here all day watching me debug JSON, which, although that might be fun for some of us, I'm not sure we'd really like it very much. What ENI boils down to, though, right, is network access. So what does an ENI do? Controls the network access to and from your task. You needed to do an image pull. So we control access to ECR through roles for ECS and Fargate. Lets you do log push into CloudWatch. If you want to be able to pull image access or you push your logs, you need outbound internet access. So that's because if I want to be able to pull something to my container or push logs off of it, I need some sort of channel to send that over. So even if the application running on that container does not require internet access, I do need outbound internet access in order to push logs or pull images. Two options here, though. You have private task with outbound internet access, which means that you can't have inbound traffic, or you can have a public task, which then has inbound and outbound traffic. So stuff that you can control in the security groups, stuff you control with network ACLs. Security stuff, I always recommend that if you're giving me kind of a blank look right now and you don't know what I'm talking about for security groups or ENIs, I definitely recommend looking into it before something naughty happens. Otherwise, there's always the blog post that's like, well, my security group had traffic to 0.0.0.0/0, and I have no idea what happened. Like, people just got in. So please security group responsibly. Please network responsibly. Please allocate public IP addresses also responsibly. But you can have outbound traffic without inbound traffic also. So if you just need image pushing and pulling and log pushing, you can just have outbound. Load balancers. So I did a little summary this morning also. 3 types of load balancers now. There used to just be the ELB Classic. ELB Classic is still around, but is not supported for Fargate. So just a couple of, and in general, I would steer away from ELB for the microservices, because I think you can get much more efficient usage from an ALB or an NLB. So the short answer to that is previously, when I had no other load balancer choices, since I map basically a service to a load balancer, I'd end up with a list of load balancers that was this long. So that was fine, and it was really nicely organized, and I appreciated that. Not super efficient, because it meant that every time I was adding a new service, I was also adding a new load balancer. And since I don't always test all of my services in production, that also meant that I had a different copy of my ELB for my staging service. So I ended up with a whole ton of load balancers when my use case really didn't need a lot of load balancers, and it leads you really nicely to the next problem, which is, Abby, I'm out of ports. And then it leads you to my next problem, which is, but how do I do service discovery? How do I know about my whole giant list of load balancers? And how do my services know to talk to each other? You worry less about service discovery in Fargate, but the load balancer answer to that question is that if you use application load balancer, you can do the path-based routing, and you can remove one of your resource constraints, which is ports. So dynamic port allocation, but I find that the path-based routing is really very nice for microservices, because I can share that one load balancer can serve multiple services by adding multiple target groups. So I've then replaced my big chunk of load balancers with a much smaller subset of application load balancers. So it ends up being a little bit less infrastructure to manage, a little less places that I know that I need to update, a little less things that I need to spin up when I create a new service. So only ALB or NLB with Fargate. Obviously, you don't have to have a load balancer, so we'll do a little demo app in just a second. You don't have to have one, but I recommend it. ALB will require you, by the way, that you have at least some kind of high availability. So you have to have at least 2 AZs, and you have to have at least 2 subnets. Do you have a question? Sure. You have to speak up a little bit louder.
Yeah, how about host header validation instead of path validation and using the route
So generally people use that for like service discovery, so that I can discover new services through Route 53. Is that what you're trying to do? Correct, but I would say that how I would use application load balancer for I'm really jet lagged, by the way, so it's really hard to say service discovery over and over again. Two different ways on this. So with Route 53, yes. So if you're using Route 53 for service discovery that way, so you're adding new DNS entries for each new copy that comes up. So I've done that for something that needed like WebSockets, for example, where I wanted to, in the interest of better response time, where I wanted to make sure that I was connected through the same WebSocket, you can use like an allocator service and add a new entry in Route 53 every time. Yes, you also could do like host routing instead of path-based routing, but I think path-based routing is a better fit here, though, because I'm not necessarily mapping at the host level anymore. So I don't necessarily want to just point. There's lots of things happening on that box other than just my one service. So what I'd rather do is be more specific, and I'd rather point it at my service, so my target group, and then let the service figure out which copy of the task to send that request to. So you can route on the host level, but I would prefer to route in the path level, because then I can distribute my traffic between the multiple copies running of the task. Does that make sense? Cool. I'm happy to take questions, by the way, as we go along. So if don't be shy if you have another question. Your question is on video, though. So if you're participating in live question and answer time, you're on video, which is totally fine. So I was supposed to repeat the question, which is why I'm now telling everyone. So if someone asks a question on the video and I don't repeat the question for the video, please tell me to stop and I will repeat the question. Okay, any other questions before we carry on? Cool. Permissions. I always talk about, every time they let me do a deep dive, I feel like I'm like, guys, dynamic port allocation. And everyone's like, God, why do they let this person do this? And I'm always really interested in talking about ports, and no one is interested in talking about ports with me. So someday I'll just do a session and it will just be on ports. Permissions, obviously we care about this. So how do I determine who can access and write things to my cluster, who can get the information that gets out, who can create tasks, describe tasks? That kind of thing is important. Since this is an AWS conversation, we use IAM for that, which I'm sure is a move surprising no one. You have a couple different levels here, though, that you need to worry about. So the first one is your cluster level. So that's a use sort of thing. So can I, as a user, create and describe tasks? So it's cluster level, meaning I can access everything that would be a part of that cluster if I was managing it, but it's more like a user level permission. The second one, you have application level permissions. So what resources can that application access? And then you have AWS permissions, which have been very kindly called housekeeping permissions, but that's stuff that you let us do. So that might be things like garbage collection. It might be helping you pull images from ECR or a different registry. It's adding targets to your load balancer. It's creating those network interfaces for you. So you have AWS permissions, you have you permissions, and then you have your actual application task container permissions. We already talked about those. Those are IAM policies. Speaking of IAM, though, there was a really nice update to how you can make IAM policies where it will actually help you see what you're doing with the IAM policy, which I actually found very interesting. So this is not related to Fargate at all, but check out IAM console. Got some exciting new changes that will help you make the policies, which I think have always been a little frustrating to make sure that you're getting right. So not related. I do not work for the IAM team, but check it out anyway. I think what's more interesting here, though, are the application level permissions, because you care about all three types, but one of them is, can you perform operations? One of them is, can we perform operations? But this is, I think, where most people get tripped up. So what does your application need access to in terms of other AWS resources? What kind of credentials does your task itself need? And remember that we're managing all of these at the task level now. So it's not just one security group or one IAM role that belongs to everything. It's one per task. So I'm waiting for my spinning VPN window to go away. This is going to be the video. People that aren't here are going to be like, why is this person always trying to connect to the VPN? But I really need it this time, so I can't just ignore it. So we talked about this morning again, but I need to do it at the task level so that if I have one task, it doesn't have access to things that it doesn't need access to, so I don't have a shared permission role. I'm not sharing anything. I'm controlling access to other services based on what each task needs. Housekeeping permissions, these are the AWS ones. If you want to talk about these, we certainly can, but this is what Fargate needs permission to in order to help you manage things. So pull images, get CloudWatch logs, create target groups and ENIs for you. If you've been working with AWS for a while, you know that there's a concept of roles here. So we have IAM roles, but you'll also have execution roles. So that's what lets Fargate do things for you. So that might be an IAM role that allows you to pull images from ECR. It might be one that allows you to write logs back to CloudWatch. But different types of roles will let you perform different sorts of operations from Fargate. So a service role will be something like a role that ECS can use to create clusters. You don't have to do anything with this. This is just an explanation of what it does. So the service role is what allows ECS and Fargate to do what it's supposed to do. This is not something that you have to manage yourself. So you have cluster permissions, who can do operations in your cluster. You have applications, which is what permissions can your applications use to do operations. And then housekeeping is what lets AWS help you manage things. A couple of to anything else. How does storage work in Fargate? It's backed by EBS. the space that your container file system gets is 10 gigabytes. So I'm not sure if that's floating around anywhere in the documentation, so that's the answer to how storage works. I talked about this morning, and I mentioned it again because no one else seems to know about it, and I think it's really interesting. Hybrid clusters, which is also the answer to the debugging question, which is how do I debug things in Fargate versus EC2? You do it by doing EC2. And I've gotten a lot of good feedback over the last couple of weeks from people saying, I don't want to manage my cluster still, and I like using Fargate, but I also want to be able to access the actual tasks rather than switching it over to type EC2. So a lot of people had that use case that they're interested in seeing. So that's something that we're talking about, of seeing about how you can do debugging of a style that's closer to EC2, closer to task type EC2, but with Fargate. So that's a very common question. So if you have more questions about that, I'm happy to talk about debugging. Let's do cooler stuff, though, because I am also bored of talking about Fargate. So let's do something fun. My computer does not like the HDMI cable, by the way. OK, so some unrelated plugs. Everyone is probably familiar with the AWS CLI. So there's two CLIs that work for containers. There's the regular AWS one, and then there's an ECS CLI. The ECS CLI will let you use Docker Compose files. So it's not the same as the mainstream one. It is supported by the ECS team. So you have a couple different options. So this is not my project, by the way, the one that's up. This CLI for Fargate is really very excellent. It's maintained by a guy named John Pignotta, I'm pretty sure. I think it's John. Paul would know. Anyway, this is really good. So if you're looking to get started with Fargate, the AWS CLI is fine. I actually really like this one. So it's on GitHub, but it feels a little bit more like a Docker Compose-y way of doing things. So like Fargate task web, or like Fargate run task X. So I actually really like this. So if you're looking for a slightly easier way of working with Fargate, maybe check that out. I'll post the link in the deck. But the website that's easy to remember other than his GitHub handle is somanymachines.com/Fargate, which I actually think is funny also. Okay, so I spoke this morning about how this blue bar looks very uncool, but it's pretty great. So I highly recommend this. So I definitely did not think that I needed to use the first run wizard, but it's actually pretty great, so hear me out. So if I wanted to get started with Fargate, you don't have to use this, but I recommend it. So there's a demo app that will help you walk through this. So, and I keep saying this all the time, but Fargate demos are not always very exciting demos, and they're not exciting for a reason. So if I went back and did the same process with ECS, it would be a lot more involved. So I think Fargate's a little funny to demo because I feel it's like, well, this demo is cool because it's the absence of this other really long list of things that I previously had to do. So we're just going to start our demo app. I'm not going to do a load balancer for this one because it doesn't need a load balancer, but I also, in typical Apple fashion, no longer have an Ethernet port. So it's not making my life any better. And now we're going to connect again to the Amazon VPN. It's really fun for everybody. It's not going to work now because my internet left. Internet is killing me here. Okay, so this is all I did. So I named my cluster High Stockholm, which is creative of me. We're going to do a little mini demo app. It set a bunch of values for me already. So it set 512 for memory. It's going to use port 80, pretty standard. So that's it. So if I don't choose to edit anything, then I'm good. So we'll see if I lose my VPN connection again, and then we can start this whole exciting process over again. But that was it. So it's doing a bunch of things for me that previously I would have had to manage myself. So part of the setup process in ECS is that it works great once you have it up and running, but there is a fairly significant amount of kind of like scaffolding type stuff that you have to do around it. So you have to have a VPC, you have to have multiple availability zones, you have to have multiple subnets within the availability zones. So there's a lot of stuff that, like prep work, that has to go into being able to run your containers this way. So I just let Fargate take care of it. So I gave my cluster a name. I chose not to mess with anything, although I could have taken that opportunity to change a load balancer, change the resource limits. If I wanted to run 4 copies of the task instead of 1, I could have done that. But alternatively, I can just let Fargate do it. So I did a demo. I did like a demo sample task definition. There's also an Nginx sample one, but you also can use the little wizard thing. I could have put a custom task definition on it. So anything that you guys already had for ECS with I think a couple tweaks you could do for Fargate as well. So that was it. So I've now deployed my little app, and this is at the point now where there's other stuff that I could do. So I could scale my cluster up, so I could make like 2 instead of 1, but it wants me to do auto scaling, which I don't. But it was pretty much, oops. So all I really did was let the wizard do it. So I didn't really pick any, I picked resources, but I just accepted the defaults. And then I'm up and running. So that was my launch process for Fargate as opposed to ECS. Works pretty much the same way, but just with a little less work. Does anyone have questions about what we're talking about or what we're doing right now, or anything exciting? Yes.
Do you recommend having a separate account for this? Because all of these research make me pretty nervous because it sets up security groups and all over the place. What is your recommendation for this? Create a new account, connect it with your...
So this is my same account. We can, yeah. Oh, thank you. You guys are much better at this than I am. So the question was, I just let the Fargate wizard set up a bunch of networking stuff for me. Is that something that I'm concerned about, or that I would recommend doing in a separate account? Short answer is, if the way that you're set up is you feel more comfortable testing anything new in a separate account, that's totally an acceptable choice. I'm working in the same account. I also find that that's an acceptable choice. And we can look at what we're doing. So why did they make Chrome full screen like this? It's terrible. If anyone works for Chrome, I'm sorry. I lost my train of thought. Yes, so I let the wizard do something for me, and I let it take over the VPC stuff for me. I can edit those security groups, and I could have done it not with the wizard and passed it a VPC ID instead. So for demo purposes, I let the wizard do it. That's not the only option. Generally, we don't. So Fargate is general availability, right? So we take security very seriously. So we wouldn't let people use it if it wasn't secure. But it is a totally common architecture choice that people like to keep stuff that they're playing with in different accounts. So that's also totally fine if that works better for you. I obviously am not running production infrastructure in this demo account, but it might be fun if I was. So both of them are acceptable. If you want to do it in the same account as your production and you want to be extra cautious, you can definitely just not follow the wizard, and you could pass it a VPC ID and pass it security groups. I know that I am not able to pass it a list of subnets without messing up at least one comma or set of brackets. So I skipped that part in the demo. But yes. Other questions? Okay. We can go back also and we can look at what it did. And we named it Hi Stockholm. And I lost my internet again. So at some point on using the internet, because I get weird errors every time because it doesn't have any internet, so it thinks it can't actually list anything. But I can actually list things in my own AWS account. Okay, well, while we're waiting for my internet to return, I think something else that's important to point out with Fargate is that most of our roadmap is generally based on what customers are asking for. So what your feedback is and what your comments are and what your question is and what you're looking for from services. So I passed a couple of threads around on Twitter soliciting feedback, basically. So with Fargate, with every other service, if you have something that you want us, if you have something that you're interested in seeing, or you have a question about something, or you say, hey, actually, it'd be cool if it worked this way, or do you think you could support this? Let someone know, because that's what drives a lot of our roadmap. So definitely, you look like you have something that you'd like to add to the roadmap. Huh? So there is Windows support in ECS. Are you looking for Fargate Windows support? Okay. Like that. So totally happy to take feedback, totally happy to take questions. He asked for Windows support, by the way, since I'm repeating it for the camera. So yeah, so lots of opportunities. So let your account manager know, let one of us know, tweet me and let me know. That's all fine. So if you have something that you want to see, or if you have something that you'd want to look at differently, or if you're not really sure how something is working, please ask someone about it. So this is the thing that the demo one that I just made. And it created these resources for me, but there's still things that I can use and edit and play with. I have a lot of security groups, and you can tell that I'm not using an exciting feature, which is labels, because apparently I never went back and edited any of them. So we'll play a fun game called Look Up My Security Group ID. So this is one that we made for Fargate. So this is a demo app, so I just opened it up, but I can edit. This is just a regular security group. So I could make it just from another security group. It works the same as everything else. So the demo is helping you set up a demo app, but the resources that it creates, it's a lot like CloudFormation resources. It's just creating a CloudFormation stack. So it's creating things that I can edit and modify and play with and change just like I could anything else. So I just have broken my app because I changed it to a different security group, but it just creates the same resources as like with anyone else. So I can do the same thing with the VPC that it created for me. I'd have to go back and look up the VPC ID, but I can add subnets and availability zones. I can change the routing tables for the VPC that I created through the wizard as well. Some things that might be interesting to look at. So I mentioned this earlier, is the awesome ECS. So this is it. So this is getting expanded right now for Fargate also, but this is a project that one of my coworkers has been working on. It's just a repo named Awesome ECS. But what he did is that he's been creating or finding people's blogs and tools that they've made and talks that they've given around these different tools. So there's a bunch for ECS that's now working for Fargate too. He put out some example CloudFormation templates on how to create things. So I could run one of these templates also. So here's a public VPC. I can do this. It's not an S3, so I need to make it. I can pass it a URL and I can use his template, and it can help me set up some of these resources. So if I don't want to use the Fargate wizard, this is maybe a good place to start. So there's a public VPC one. There's a public and private VPC one. He's limited them. And then there's some stacks on top of that. So how to create the actual subnets and the load balancers. So there's a bunch of places to help you get started. I like the wizard because it shows me a lot of what I'm doing, but it also let me get from kind of zero to working demo app really quickly. So I didn't really have to fiddle with everything. It just kind of started up. I could have used that same wizard, by the way, if I had an existing task definition that I wanted to use from ECS. I could do the same thing. So from my wizard thing, I probably lost internet again. This is great. Why did they get rid of the Ethernet port? Does anyone have an answer to this question? Because I really kind of miss it. I still have lots of ports compared to the new one, but apparently none of the helpful ones. So weirdest decision. So if my internet ever comes back, but from the same process, world's most terrible demo, by the way, but from the same process, I could definitely take something that I had already used for ECS and I could use it in the same thing. So copy and paste it and let Fargate handle the rest. Alternatively, you can follow the same setup process that you do for ECS. So you could create it from the CLI, you could create it from the console. Same thing, just change the launch type. And obviously, I have no internet. So on that extremely positive demo note, does anyone have any questions that are not about my lack of internet? Or if you don't want to ask your question for the video, we'll be wrapping up in 1 minute. Yes?
What are the ways Fargate can fail?
Can fail?
Yeah, something must be wrong.
Well, well, that is very philosophical, and I appreciate it. Well, we just saw a bunch of ways in which I can go wrong, which is that it turns out that if you interrupt your network connection in the middle of a console operation, it returns an IAM error, which I thought was interesting. So that was a fun fact for everyone, and I learned something new today too. In terms of Fargate failing, it's kind of an interesting question. In general, functions a lot like ECS. ECS has 4 and 9s SLA. Ways that it can fail. So from a number of years of using DevOps, doing DevOps and using ECS and container stuff in AWS, the biggest ways that things fail are me messing up ports and security groups. So that's the number one. I would say that my biggest actual like ECS container related thing was a half and half one between me and AWS. So when ECS first came out in beta, there was no validation preventing me from changing the load balancer name. So I thought that I could, for a while, I could very happily register and re-register it with different load balancers. That's not actually true. So one day I got to work and nothing worked. And I was like, wow, I haven't changed anything. It's like a Monday and I haven't been in since Friday. And there's really no reason why none of my tasks should be failing to deploy anymore. I don't think I've changed anything. And I'm sure after chasing down a bunch of developers and demanding to know what they changed, turns out that validation had been added. So I would say that the biggest way that things can fail with something like that is that was a miscommunication, that there was validation added. I had missed the release notes for it and a process that was updating the family to make everything kind of look nice and have a nice naming scheme. I had totally missed that, so I messed it up, but I was very upset about it. In terms of Fargate itself failing, I think it's pretty much like any other managed service. I mean, sometimes in the past, there have been outages in an availability zone. So something like that could happen. But in general, the managed services are very stable, and people wouldn't use them if they weren't. Also, we wouldn't want you to use them if they weren't. So we take that kind of stuff very seriously. Yeah?
When we specify the auto-scaling, do we specify the machine type?
So you don't have to do the... Oh, sorry. Everyone is on top of me. In my defense, I got up at 1 a.m. my time, so I'm not sure I'm really awake. The question was, do we have to specify the machine type when we make an auto-scaling rule in Fargate? So it's not cluster-level auto-scaling rules in Fargate now. It's only task-level auto-scaling rules. So I'm not changing anything in my container. So if I look at my cluster type and my When I register it, I'm registering the load balancer, but I don't have to, I'm not choosing a machine type because there's nowhere to choose it from. So I'm not running the cluster resources anymore. Is that the question?
So the cluster doesn't go into my VPC, it will go to a separate VPC.
You're in your VPC, but you're not doing the cluster auto scaling.
But my real question is, Beanstalk multi-container is a simplified way of running ECS, and now Fargate is another simple way of running ECS. Do you have a clear comparison, short comparison between Beanstalk and Fargate?
Kind of. So
Beanstalk, you define your cluster on your own. You define VPC, cluster, machines, and etc. as well. But here it seems that that part is taken away.
So to repeat what I believe is a summary of the question, and people can tell me if I'm wrong, but looking for a comparison, that it seems like Fargate and Beanstalk are both relatively simplified versions of ECS, but in Beanstalk you define your own cluster, and in Fargate you do not. Is there some sort of summary between the differences between Beanstalk, Fargate, and ECS? Really short summary. ECS lets you control all the pieces. So you're controlling the containers, you're controlling the container definitions, the task definitions, your cluster resources. So that means the AMI that makes up the instances in your pool of cluster resources. You're controlling the containers themselves. You're doing all of that. Fargate is kind of a simplified version, but not really, because Fargate ultimately is what will also support EKS as well, so you'll be able to run EKS tasks with Fargate mode as well. So Fargate mode it's closer to the AWS managed service way. So I take responsibility for some things, you take responsibility for some things, so it's like a shared responsibility model. So Fargate's a lot like that for ECS in that I still have the same things happening underneath. Tasks are still being scheduled the way that I want and placed the way that I want, only I'm leaning on Fargate for a little bit more of that. So I have my pool of cluster resources, but rather than managing the cluster resources, I'm just managing the tasks and allocating them and scaling up at the task level. Beanstalk, which I have not used in a while, so you can correct me if I'm wrong. Also, the VPN man. Beanstalk, I believe, for containers, it's kind of like half and half. To me, the Beanstalk version of doing containers feels a lot like what you would consider simplified ECS. It's ECS, but it's helping me set things up, and it's helping me manage some of them. So I think you can use, as for a lot of things, I think you can use Beanstalk and ECS and Fargate to all can solve a similar type of problem for some people. So you choose what works for you. What I like about ECS and Fargate is that ECS lets me have control over everything, and I can migrate back and forth very easily from a launch type of Fargate and from a launch type of EC2. So if I want to control everything about my cluster resources and my tasks, I can do it in the EC2 type launch type for ECS, or if I want to let something else handle that, I can just run them in Fargate mode, which means it's the same thing as before and the same definition as before, so very portable, but I don't have to manage the underlying resources. But I am not super up to date on Elastic Beanstalk, so there might be something that I do not know about Elastic Beanstalk. And by might, I mean there's almost definitely something I don't know about Elastic Beanstalk. So if there are any other questions that people want to ask right now, yep, go ahead. I do not have a timeline on additional regions, but we add new ones all the time. I don't have a timeline, though. Any other questions now? If not, I will also take questions here if you did not want to ask your question on the recording. And with that, I will let everyone go. You have 8 minutes until your next session. So thank you for coming, and I will possibly see you here again.